Welcome to the section on definition 1 trigonometric function. And we finally begin with trigonometry. First of all, the definitions of the trigonometric functions are very important and need to be memorized. Since you need to use them all the time, it would be way too inconvenient to have to look them up all the time. Also memorize in which quadrants each of the trig functions are positive, respectively negative. So let's finally start with trigonometry. The definition is that sine of the angle theta equals the coordinate y over the radius r. So y over r. I frequently actually just use the words opposite and adjacent, which actually takes from definition 2 in the next chapter. I'm just so used to them. So here, cosine goes with the x-coordinate, respectively the adjacent, divided by the radius r or hypotenuse r. And between x, y, and r, there's a third way to combine them, and that is the opposite divided by the adjacent. Y over x equals tangent. These are the three main trigonometric functions, and with that we're actually done with the course of trigonometry. Unfortunately, that's not the case. There's a lot more to it, but really these are at the heart of trigonometry. Each of them has what is called a reciprocal function, reciprocal function, and they're simply the reciprocals of these here. So for sine theta, that would be cosecant theta equals, well, the reciprocal is going to be r over y. You don't necessarily, well, yeah, you do memorize these as well here as being the reciprocal functions, but they're not that important as sine, cosine, and tangent. We do come frequently across them. In fact, you can see that on your calculator that they don't seem to be that important because you don't even find them on there. On your calculator, what you would have to do is, if you want to determine the cosecant of an angle, you would actually have to type in 1 divided by sine of the angle. The secant theta is the reciprocal of the cosine, so it's going to be r over x, and the cotangent theta is the reciprocal of tangent, so x over y. I might as well write them in here: 1 over sine, 1 over cosine, and 1 over tangent. Okay, that's actually all that goes with it. Let's just look at this here and just do one quick. No, let's leave it at this. We're just having defined the trigonometric functions. Now let's quickly look at it. I made up my mind again. Let's just quickly look at it on a graphing calculator. Let's say we have an x here of, looks like 3.5, and a y of, looks like 4.5. So x equals 3.5, y equals 4.5. In my drawing, of course, these are arbitrary numbers anyway. They are supposed to go for any kind of x, any kind of y. And then, of course, we have a radius r of, when we type that in with the Pythagorean triangle, we come up with 3.5 squared plus 4.5 squared. I do this on the side here, take the square root of that answer, and I come up with r equals 5.7. Notice that the angle doesn't exactly look like 45 degrees. In fact, the y is longer than the x. Maybe it's around 50 degrees. So let's figure that out. In fact, I can measure it manually here. And I come up with actually kind of 55 degrees. Roughly 55 degrees. So let's go to the graphing calculator and we'll see how we can type them in. I'm only, so let's go over there. Okay, that's still from the last section. I think I'm just going to clear everything out here so it's not in our way. Okay, I said y was 4.5 and the r came out to be 5.7. And it would be the sine, and we had an angle roughly measured to 55 degrees. And that's pretty close. Actually, I'm going to do on the side the correct angle. I'm not going to show you just yet how I do that. You will learn that very soon. The exact angle is actually 52.1 degrees. So let me do that. Sine of 52.1 degrees. I'm using my keyboard at this point. And there you go, 0.789. The cosine would be the adjacent, or the x-coordinate, which is 3.5, divided by the radius, which is 5.7. Enter. 0.614, respectively cosine of the correct angle of 52.1 degrees, 0.614. The tangent would be the opposite of the adjacent, 4.5 divided by 3.5, enter 1.28. You might have noticed actually something that both the cosine and the the cosine and the sine were smaller than 1, and that will be always the case. They could be as large as 1, but smaller or equal to 1. Well, the tangent, in fact, can be larger than 1. And again, tangent of 52.1 degrees, enter 1.28. Here's one important thing to point out. If you try it on your own graphing calculator and you come up with something that's not correct, do the following. Go to Mode and make sure that the third one down here is on degrees. So if it's accidentally on radians, change it to degrees. Mine obviously was already on degrees. In order to figure out what the cosecant is, for example, I would have to turn them around. So I would say 5.7 divided by 4.5. So the cosecant actually comes out to larger than 1. And then we're doing 1 divided by sine of 52.1 degrees. And that comes out to 1.26. As you can see, the calculator does not have the cosecant, secant, and cotangent functions. So whenever we do that, we have to use 1 divided by sine, or 1 divided by cosine, 1 divided by tangent. With that, I'm going to go back to the lecture in Word, and here memorize the above definition. Okay, I mentioned the following one here already. The sine cannot be, or is always smaller, or at most equal to 1. We will see that it can be as small as -1. That will happen, for example, if we're in the second quadrant where the y is negative. Now obviously we're going to come up with a negative number. Y smaller than 1, y never larger. Well, the definition is the y-coordinate divided by the r. The r is the hypotenuse of this triangle, which is always the longest part of the triangle, so it has to be larger than y. So we always come up with a number that is smaller than 1. And at best, if we really push the y here towards the y-axis and make the angle 90 degrees, then the y and the r would be equal, and we come up with 1 for the sine. I'm pretty sure that over here I meant to put in that the same thing is true for the cosine. Again, the x is always smaller than r, or at best as long as we push the x out here and get the r closer to the x-axis, the two actually could become equal at an angle of 0 degrees, and we come up with that the cosine is 1. The cosecant, which is the inverse of the sine, the cosecant is, let's see, cosecant is always larger than 1. Oh, this probably says cosecant and secant both are always larger than 1, or the two are always smaller than -1. That comes naturally that if the sine is less than 1, then the reciprocal of it has to be larger than 1. Or if the sine is between 0 and -1, then the reciprocal of that has to be less than -1. So the cosecant and secant are always larger than 1 or -1, never in between. The tangent and the cotangent are simply anywhere in the realm of the real numbers. So they could have any values. You can see that the y could be relatively small and the x could be large, and so we come up with a small number. Or the y could be relatively large and the x is relatively small and we come up with a large number. Or one of them is in the negative and we come up with a small negative number or a large negative number. We will also see that later on when we're graphing. Okay, cosine. The cosine is on the x-axis, as we see here, x and r. So cosine is on the x-axis, positive or negative. When the x is positive, that means in the first quadrant as well as in the fourth quadrant, the cosine is positive. So in quadrant 1 and quadrant 4. When the x is negative, that means in the negative direction here, and that means in the second quadrant and the third quadrant, the cosine is positive. The r, the radius here, is naturally positive, so as we divide the positive x or negative x by the r, it doesn't change the sign of the x. The sign is associated with the y component or y coordinate or opposite. So for the y to go up here, the sign would be positive, and that happens in quadrant 1 as well as in quadrant 2. And when the y goes down, which happens in quadrant 3 and quadrant 4, the sign is negative. The tangent, which we will soon see as that the tangent can also be defined as sine of theta or cosine theta. That's what I mean to express here. We will see that in the later section pretty soon. We determined that it is, let me actually go down a little bit, is positive in quadrants 1 and 3 and negative in quadrants 2 and 4. That also can be seen that in quadrant 1 we have a positive y divided by a positive x. In quadrant 3 we have a negative y divided by a negative x. So again, we come up with positive tangent. And then in quadrants 2 and 4, we have a negative divided by a positive, or the other way around. I just want to show that in Paint, and as a last note on here, memorize the above sign assignments. So I'm just going to go to Paint over here. And with that, I will conclude this lecture. So the cosine is positive in the first quadrant and the fourth quadrant because it goes with the x component, and it's negative in the second quadrant and the third quadrant because the x coordinate would be negative. The sine would be positive. I want to do this in red. Would be positive in the first quadrant, positive in the second quadrant because the y goes, because the sine goes with the y, and then it's going to be negative. I want to do this in blue. In the third quadrant and fourth quadrant because then the y, of course, is negative. The tangent, let's see, I want to do this in red, is positive in the first quadrant because we divide a positive y by a positive x, and it's positive in the third quadrant because we divide a negative y by a negative x, negative in the second quadrant because we divide a positive y by a negative x, and negative in the fourth quadrant because we divide a negative y by a positive x. And as I said, with that I conclude